Alright, you've got an antique car jack which is filled with a fluid, and on top of the fluid sit some pistons. One's a larger piston, 1.1 inch in diameter. Then there's a small piston of 0.38 inches in diameter. We want to determine the force F needed to support a 1,000 pound load at the output piston. So you got a 1,000 pound force that's being pushed up by the liquid. So we want to find the pressure at piston 2, and that would be the force at piston 2 divided by the area of piston 2. But the pressure at piston 1 has to be the same as the pressure at piston 2. Yeah, the pressure at piston 2 is F2 over A2. Pressure at piston 1 is F1 over A1. Assume that the pressures are equal at both points as long as they're at roughly the same elevation. So in that case, F2 over A2 would equal F1 over A1. So you can plug in what you were given. Let's see, force 2 can be the 1,000 pounds. That's what the big piston is holding up. Its area would be pi times its diameter over 2 squared, so we get pi r squared basically. Then over here we would not know force 1, but we can plug in the area of the piston for that location. So we would have 0.38 over 2 and then square it. Now we can solve for F1. So it turns out that F1 looks like 119 pounds. Alright, but that is not necessarily going to be the force applied here, though, because this problem combines the statics of fluids with torque. So the force on this piston is going to be, there's a downward force due to this device, and it's going to be 119 pounds. And so that means that that rod is going to push up on this beam also with 119 pounds. Now we know that the beam is not moving. It's in static equilibrium right now because the force applied is creating a torque which cancels with the counterclockwise torque. What you want to do is say that the upward torque has to equal the downward torque. They have to be balanced. So you'd say that the 3-inch lever arm here, which points from P to where the force is applied, will get multiplied by the 119 pounds. And then for the downward torque, we need a lever arm which goes all the way from point P to the end of the rod, which is actually 15 inches. And then you could solve for the applied force required. And since the person has much more leverage, we expect that the force that they have to apply is actually not as large as other forces involved in the situation. So that's where the mechanical advantage comes in. So force applied then will be, looks like 23.8 pounds.